Okay, here we want to see how to find the inverse of a 2 by 2 matrix. There are multiple ways to find the inverse of a matrix, but we want to use the most common method that's used, which is 1 over the determinant, and we solve it by switching the main diagonal and then negating the minor diagonal. Now this is what we do. A inverse equals 1 over the determinant. Now, how do we find the determinant? The determinant is found by 3 times 4 minus 5 times 2. Cross multiplying. I'm going to say it again. 3 times 4 minus 5 times 2. So 3 times 4 is 12 minus 5 times 2 is 2. So the next thing that we need to do here, we want to switch places of the 3 and the 4 on the main diagonal. So that's going to be 4 and 3. And then what we call the minor diagonal, we negate it. So that makes that negative and that's negative. So that's going to give us negative 5 and negative 2. Okay, now we basically use scalar multiplication as we've done before. So we come down again. 1/2 times 4 gives us 2. 1/2 times negative 5 gives us a negative 5 halves. 1/2 times negative 2 is negative 1. And 1/2 times 3 gives us 3 halves. That's the inverse. We could always check it. If we multiply the inverse times the original matrix A, we will get the identity matrix, which was 1, 0, and 0, 1 going across. Okay, let's try the next example. B inverse. Now remember what we need to do in this case. We're going to make that negative. Let's see what we need to do in this case. We have 6 times negative 3, which is negative 18, minus 3 times negative 7, which is negative 21. Negative 18 minus a negative 21 gives us 1/3. Okay, then we have to remember what we did earlier. Remember, we changed positions of the 3 and the 6. So that gave us a 3 and the 6. And then what did we do? We had to negate the other one. So this made the positive 3 into a negative, and this negative 7 into a positive. So we're going to go with that. So this is going to be what? 7 and negative 3. And now once again, we use scalar multiplication. 1/3 times 3 gives us 1. 1/3 times negative 3 gives us negative 1. 1/3 times 7 gives us 7/3. And 1/3 times 6 gives us 2. Okay, now for this last matrix, we look at it and we have to remember something that we learned a long time ago in algebra. But once again, we find the determinant. We know that the inverse is going to be 1 over the determinant. But when we do it this time, we're going to notice something. 3 times 8 minus 4 times 6. That's 24 minus 24, which gives us what? 0. One of the first things that we learned was that you can never have a 0 in the denominator of a fraction. It was undefined. So there's no need to even go forward with moving these numbers around. We can just say what? That the determinant is equal to what? The determinant of D is equal to 0. Therefore, D is not invertible, which that means we cannot find the inverse. So these are just 3 quick examples of how to find the inverse of a 2 by 2 matrix. Remember, there are several ways. There are methods where we could use the transpose. We'll learn that later. There are other, like I said, there's several ways to do it, but this is the most common and the most straightforward way that we use it. Now, of course, we can't use this method when we use a 3 by 3 matrix. We have to use what are called row operations, but that's down the road. So here we have